You think nothing can go faster than light? Everyone knows that. It's the rule, the cosmic barrier. 299,792,458 meters per second. The ultimate limit. Fine. But why? What actually enforces it? Why can't you just push a little harder, add a little more energy and break through? Most people stop there. They nod and move on. It's just how the universe works. But that's not understanding. That's surrender. When you really chase down what's preventing anything from exceeding that speed, when you peel back the layers of reality itself, you uncover something so profound, so alien to everyday intuition, that it shatters your sense of space, time, and causality. The speed of light isn't a limit slapped on top of the universe. It's the foundation. It's the speed at which reality propagates. It's the rate at which causes connect to effects. And what was uncovered through relentless probing reveals that going faster isn't hard. It's impossible. Meaningless. Let me take you there. Start with something familiar. Clocks. Two perfect clocks, identical, ticking in sync. You keep one on the ground. You put the other on a rocket and send it screaming around the world at enormous speed. When it comes back, the moving clock is behind. It ticked slower. Time passed differently for it. This isn't a trick. It's not damage from acceleration. It's measured over and over. Atomic clocks on airplanes lag behind their twins left on Earth. But wait. From the rocket's view, it's the Earth clock that's moving. So shouldn't the ground clock be the one that's slow? Both can't be right. Or can they? This paradox gnawed at physicists until the realization hit. Time isn't absolute. It's relative. The faster you move, the slower your time flows compared to someone at rest. But how much slower? The formula ties it directly to the speed of light. Divide your speed by that number, square it, subtract from 1, take the square root, and that's how much time stretches for the mover. The closer your speed gets to that magic number, the more dramatic the slowdown. At 99% of it, time crawls to a fraction. At 99.999%, it almost stops. And at exactly the speed of light, time would freeze entirely. Zero flow. But something moving at that speed experiences no time at all. Now think about length. A rod perfectly measured at rest, 1 meter long, now hurl it past you at high speed. It shrinks, contracts in the direction of motion. Again, not an illusion. Real contraction. The faster it goes, the shorter it gets. Again, the formula involves that same speed. The contraction factor is identical to the time dilation one. Space itself compresses for moving objects. And again, as you approach that ultimate speed, length squashed towards zero. A journey across the galaxy would flatten to nothing from the traveler's view. Space and time both warp, twist, to preserve something deeper. What are they preserving? The constancy of light speed. Shine a beam from the still clock. It races away at exactly that number. Now from the moving rocket. Common sense screams that the beam should surge ahead faster, boosted by the rocket's velocity. Or if shot backward, slower. But no. Measure it. It's the same speed. Always. No addition. No subtraction. Light doesn't care how fast the source is moving. It always clocks in at precisely 299,792,458 meters per second for every observer. This invariance is the bedrock. Everything else, time slowing, space contracting, bends to keep this true. The universe reshapes its most fundamental dimensions to ensure no one ever sees light moving at anything but that exact pace. But why does light get this privilege? Dig deeper. Light is electromagnetic waves, oscillating electric and magnetic fields feeding each other, propagating through empty space. The equations governing those fields, discovered in the 19th century, contain two constants, one for electric forces, one for magnetic. Combine them in a certain way, take the reciprocal of their product, square root, and out pops the speed of propagation. That speed is built into the very nature of electromagnetism. It's not measured separately and plugged in. It emerges from how fields interact in vacuum. Light travels at that speed because that's the natural rate at which electromagnetic disturbances spread. No medium needed. Empty space itself supports waves at exactly this pace. And experiments confirmed it matched the measured speed of light perfectly. So light isn't special because it's fast. It's fast because it's pure field, massless, born to move at the universe's intrinsic propagation speed. Now push an electron. Accelerate it. It gains speed, but watch carefully. As it approaches that electromagnetic speed, something resists. Not air, not friction. The electron itself grows heavier. Its inertia swells. To nudge it faster requires ever more force for ever less gain. The mass increase follows the same formula. Divided by that square root factor, momentum surges, energy explodes upward, but velocity creeps asymptotically toward the limit, never touching it. Infinite energy would be needed to reach it. Infinite. Not a lot. Not impractical. Impossible. Massless things, like photons, must travel exactly at that speed. They have no rest frame. Anything with mass can approach but never arrive. The barrier isn't technological, it's structural. Think in 4 dimensions. Space and time aren't separate backdrops. They're fused into space-time. Events aren't just where, but when. Distances in space-time aren't measured with ordinary rulers. There's a conversion factor between space intervals and time intervals. That factor? Squared. It's the speed of light squared. It's the metric of reality. The distance through space-time between cause and effect is invariant. Everyone agrees on it, no matter their motion. Light traces paths where this space-time interval is zero, null paths. Causes can't outrun their effects because that would require negative interval squared imaginary distances, reversing time's arrow. Faster than light means signals looping backward, effects preceding causes, paradoxes unraveling reality. The limit protects causality. Break it, and the universe loses coherence. But probe quantum depths. Particles aren't just points. Their behavior sums contributions from every imaginable path. Most paths cancel in interference, but light's paths. Photons explore all routes, all speeds, even faster than light, even slower. Amplitudes for superluminal paths exist, yet they interfere destructively everywhere except the precise speed dictated by the wave equations. The net result? Light arrives as if it traveled straight at exactly that speed. Quantum probabilities enforce the classical limit. Virtual disturbances can flirt with excess, but real propagation, observable effects, stay capped. The quantum world whispers the same constraint, cause and effect chained below that threshold. Test it relentlessly. Particles smashed in rings approach 99.999999% of the speed. Their effective mass balloons thousands of times over. Energy requirements skyrocket exactly as predicted. Cosmic rays slam atmosphere, producing muons that should decay long before ground. Yet they arrive in droves, time dilated, lifetimes stretched from their racing frame. Satellites orbit fast. Their clocks run ahead slightly from weaker gravity but behind from velocity. Net correction essential, or positioning drifts kilometers daily. Every confirmation stacks higher. No cracks, no exceptions. Bring it together. The speed isn't a cap on vehicles or particles. It's the speed of information, of influence, of change itself. Electromagnetism sets it because fields regenerate each other at that rate in vacuum. Relativity reveals it as the glue holding space-time consistent across frames. Quantum paths reinforce it through cancellation. Causality demands it to keep past from future tangled. There is no deeper mechanism pushing back, no ethereal drag, no hidden break. It's emergent from the geometry of existence. Space and time trade off to keep it invariant. Mass converts to boundless energy to prevent crossing. Going faster would demand negative kinetic energy, backward time flow, unraveling the sequence of events. This insight didn't burst fully formed. It built through puzzles. Discrepancies in orbits led to light's finite travel time. Failed searches for ether forced invariance. Paradoxes of clocks and rods demanded flexible time and space. Quantum oddities of light's behavior hinted at deeper summation rules. Each anomaly, instead of breaking old laws, birthed new understanding. Each confidence in prior truth revealing the next layer. The avalanche rolls on, deeper into quantum gravity, where space-time itself might froth and foam, yet still, that speed endures as the horizon of causality. The speed of light isn't just the limit, it's the heartbeat of reality, the pace at which the universe updates itself. The boundary where time and space balance perfectly for massless wanderers. Cross it, and you don't go faster. You cease to make sense. The universe isn't cruel for imposing this. It's elegant, profound. It weaves consistency from motion, order from relativity. And that we can grasp this, measure it, predict with it, that fragile minds on a pale rock can uncover such depth. This is the true wonder. What if you paused right now, felt the weight of this structure around you? How does it change the way you see every moment, every motion, every cause leading to effect? Share that shift below. Dive deeper with others chasing these truths. Let the avalanche continue.